Welcome back, everyone. This week in this video, we have a lot to get through. I've got several PowerPoints that I want to get through, just not every single slide, but I want to touch on very specific things. And we're following along in Murex C# 7th edition. And this video, we're going to actually cover chapters 4 to 9. So we have a lot to do. But because I know that a lot of you are relatively experienced programmers already, lots of this I can gloss over and some of it I just cannot. And so I am going to definitely stop and highlight the content in this book that you really need to know in order to do maybe follow along and do the assignment or do the exercise in this video. Okay, so let's begin with chapter 4. And in chapter 4, we're really focusing on numeric and string data. Okay, so there's some really good things that we're going to be able to do in this one to test out and play around with. This one I think is going to be pretty interesting. So as you know, in software, we have these data types. And what you can see is sort of several columns here, but the one on the far left, this C# word, okay, these are the data types that we're going to focus on while we're doing C#. You can see the size of memory that they take, the number of bytes that they actually consume in memory. And then that center one here, this .NET type, and this is really, I would say, probably more appropriate to use this if you're doing some sort of .NET application, maybe more of a .NET Core web application. So if we're going to be doing desktop applications, then we want to be with the C# data types that we want to use. If we're going to be doing ASP.NET Core web application stuff, then we would be focused on that .NET data type. Okay, so even here, we've got some of the ones you'll be more familiar with, which is an integer. Okay, but in .NET, we're looking at it as an int32. But for the most part, we just want to focus on that left column. So an integer. Okay, and then there's some other ones that you're probably familiar with, which is a long, a ulong. There's a float, a double. And notice the difference between the capital D and the lowercase d. They both consume 8 bytes of space, but in reality, for what we're going to be focusing on, we'll stick to the lowercase double. And, you know, if in all other cases doing web development, it would be an uppercase double. So, you know, finally we get to this one. There's this data type called a decimal, okay, that we'll use sometimes. And notice the size of it. It's 16 bytes. Okay, so it consumes a huge amount of data. And then, of course, you've got your character type, or some people call it a char, some people call it a char, or your character type, which is a single Unicode character. Okay, and then finally at the bottom, we've got a Boolean. And really, you know, 1 byte of space, and it comes out to, it always resolves itself to a true or a false value, no matter what. Okay, so let's move on and just kind of look here at some examples of naming conventions. We don't have to spend a lot of time on this, but really the one thing it says here is a variable stores a value that can change as a program executes. Okay, so hold on to that because we're going to come back to constants. Okay, so if we now look at sort of the naming conventions, we have this idea of camel case. And I do prefer to use camel case. Some people don't. Some people like to do it with an underscore in between the words. Okay, so it just means that, you know, start the names of variables with a lowercase and then capitalize the first letter of each word after, right? It's supposed to represent the hump of a camel. And always try to have meaningful names that you can remember to your variables. I really don't think it's advisable that people use acronyms that nobody else ever reading their code can understand. Okay, so if you look here, there's in the middle of the screen, int counter. I don't think it's a good idea to change that to CTR because it's not intuitive by other people looking at your code later on. So if we look at these examples here, we've got our data type, the variable name in camel case, and then the value. Okay, so you can see all these different examples here, and notice that they are all, for when you look at, say, double as an example, it's the lowercase double that we're using. Decimal is the lowercase. Same with character or char letter A. We're using the lowercase version of these data types. Okay. So when I talked earlier about this idea of variable values being able to change, we can actually use this keyword const. And with const, it sort of locks up that value. So you can see in the examples, it says int days in November. And November has 30 days consistently year after year. So there's no reason for us to ever want to change the days of the number of days in the month of December. So we can kind of put a lock on that data value from being changed just simply by adding the keyword const. Okay, so for example, if your sales tax is 7.5%, and if that's kind of common to your region or common to the area that you're building the application for, and that's not going to change, then you want to lock that value from ever being changed by just adding the keyword const. Okay, so it really stores that value that cannot be changed once it is initialized as a constant value. Okay. There's this other naming convention, Pascal notation, where you capitalize the first letter of each word. Okay, that's another way you can do this if you choose to. Okay, so we've got our arithmetic operators. You've seen these before if you've done any. If you have any other programming experience. So I'm not going to spend much time on this, but here's the one I want to look at here is our, our incrementers and our decrementers, right? So we know that 2 pluses is the same as, say, x equals x plus 1. So it's the same as saying I'm starting with 1, which now means that 1 is the equivalent, it has the equivalent value, or x has the equivalent value to 1. And you're doing this mathematical operation on the right-hand side because there's a big difference between what happens on the right-hand side of an equal sign and what happens on the left side. Okay, everything that happens on the right-hand side of an equal sign gets executed first, and then the result of that execution then gets assigned to whatever is on the left side. So you can see here in this particular example, let's say I have, I'll do it with a pen. Okay, let's say this is 1. Okay, what this ends up meaning is that 1 plus 1 is 2. We take 2 and now we assign the value of 2 over to that x. And then this process can repeat itself. Okay, so that's really what that means. And then conversely, it's the same thing. If I were to say 2, or I start off, x is 2, then it becomes 1, and then 1 gets assigned back to x. Okay, so sort of basic stuff that if you've done programming before, you already kind of know. Okay, so you can look at these expressions. Not going to spend much time on that one there. Okay, but this is basically sort of how you would go about doing these math expressions. Okay, and I'll give you a little tip. If you're ever doing this, I do suggest that you always start writing your code on the right side of the equal sign. Get that logic straight in your head on what you want to do, and then add the left-hand side after. It's just a little trick to help keep your programming kind of in line. Keep your logic in line with your head anyway. Okay, so you can see these other examples here with different decimal types. Okay, so these are just some different examples, and you notice the little M there. We'll come back to M, which is right up here. We'll come back to that at another time. Okay, and these are obviously the different assignment operators. This is what's happening between the left-hand side and the right-hand side of your operations. Okay. All right, so this is really what I'm talking about here, right? Do the logic first on the right-hand side. Figure out what you want in your head first. And then once you're done that, then figure out what you want to see on the left-hand side. Okay, so, just to be clear, and the reason I say that is because everything that happens on this side, on the right-hand side, does a calculation first. The compiler will make that calculation first. And this is, clearly, let's see if I can get rid of the pen. And I can't get rid of the pen. Anyway, this means assignment. Okay, this is not the same as equal. And I think I've talked about this before, but this does not mean technically that total is equal to this. What this really means to say is take everything on this side, get a result from that, and then assign the result. So yeah, you could technically say, well, they are the same, but saying that A is equal to A, sorry, that's terrible. That means something different in programming, because what it really means in syntax for programming is we'd have two sets of equal signs. In reality, what we're saying is we have A, and if we have B, what we're saying is really take the value of B and assign it to A. Okay? That's really, it's a very fine distinction, but it's one that's very important to try to understand. And really, this slide is all about kind of shorthand. Instead of saying, okay, take myself, total, and then do a little equation of whatever my value is of total, and then add it to 100M. So the shorthand for this really is just by using this here. This top line, total equals total plus 100M, is the equivalent to this. So to be perfectly honest, my preference is to actually do this. I prefer this method over this method because this is much more human readable. We've been doing this kind of, our brains have been interpreting this kind of logic since we started doing math, and probably around grade 2 or 3. So for me, I find this to be cleaner, more clear code, but they're equal and you can do either one. Okay, so there's an order of precedence, obviously, with arithmetic operations. Okay, so increment and decrement first, positive, negative, multiplication, division, modulus, addition, and subtraction. Okay, so it's not quite the same as doing long division, but there is this order of precedence. Okay, so I'm not going to spend too much time on this because I think you guys have probably got some good experience already. But if not, you can pause this and look at the screen. So very quickly, there's this idea of implicit casting. Okay, you can see here, and then explicit casting. So let's go back to this for now. When we give a variable its data type, that's an example of implicit casting. So we're saying this data type for grade is a double, no questions asked. But when we go to here, we have an integer here, but we're trying to actually assign it a double. And we're going to get complaints from our compiler because we're saying, no, we want whatever is on here on the right-hand side to be assigned to the value of grade. But you're telling me that you want a double. And so we do this thing called casting. Another way is to say typecasting, like data typecasting. And I'm not referring to TV show casting, where William Shatner can only ever be Captain Kirk. Okay, so this is this example of casting. And it's an implicit cast. We're saying, hey, we acknowledge that we have a mismatch in our data types, but go ahead and take this one and actually convert it. So you can see here what I'm doing is I'm converting a double to an integer, and I'm going to get this output here. Okay, and we can do this same sort of thing here where it becomes important. You can see that we're actually, in this case, we're after an output of what the letter is. Okay, the letter A. And I believe in ASCII, it's the value is 65. So this is an example where we're taking the numerical value of the letter 65, and we're trying to get an output of what the alphabetical value or equivalent to that would be. And so this next one is a really interesting one, right? Because we've got the variable A, B, and C. Variable A is a double, int B and int C. So we've got B and C are both integers. And when we do this mathematical operation where we add them all together and we divide by 3, okay, we're bound to get an actual decimal value of some kind. But our goal is not to have it output to a decimal value. Okay, so what we can do is take that entire mathematical operation first and then cast it to the desired variable or data type. Okay, so this is why I always say just focus on the right-hand side of the equal sign first. And then once you've done that, then come back and have a look at what's happening on the left. So here we're going to sort of switch gears now and talk about some math and the math classes. Okay, so what I want you to see here is that, let me go get my pen. Okay, and what you're seeing here is that I have this, I need to do this math on the right-hand side of my equal sign. And these are static methods. And what that really means is that I can just call the math class. And I just use this sort of keyword math. That's it. I just need to call math. And that's kind of what makes it static. Okay, is that I'm calling math and I'm using this thing here, the dot operator. So I'm just saying math.round. And then I have to sort of abide by all of the parameter list inside of the round method that comes from the math class. So, you know, in this particular case, round requires a minimum of one parameter. So in my case, if I was going to use this, I would have to give it at least one argument within the brackets. Okay. And you can see here, we've got other ones for this one here for round. So you can see I'm passing one argument into the round method. Okay, and like it says here, round is just going to round it to a whole number. But in this example here, I'm passing 2 arguments. Okay, so that's an example of something called a method or a function overloading. And you've got the round method here and here. But in this case, I'm only passing 1 argument. But in this case, I'm passing 2 arguments. So they're versions of the same function in the math class. So if I want to use this, I don't have to go and create this myself. I can just call the math class and say, hey, can I borrow your round function? And I might need to use different versions of the round method. Okay, so really that's what this is about, where we can call these static methods from the math class and use them how we feel appropriate. So you can see other examples here. This is a power, so you're taking the radius to the power of 2, and you're multiplying by pi. Okay, and this is pi is somewhere in the math library. Okay, so it's really interesting because you can call from the math library a method, but you can also call sort of predefined variables. Okay, so here's another one with square root. There's the maximum and there's the minimum. So you have these different mathematical functions in the library. Okay, so let's say you've got option A, you can write all that code yourself, or you can say, no, I'm going to go to the math library and get out the book that tells me how to, or just gives me everything I need for minimum and maximum. Okay, as opposed to rewriting the book yourself. You're going to go to the math library, get the book that's specific to that and use it. Or the other option is you're going to just write your own book altogether. And you'll see what I mean when we maybe get into classes at another time too. Okay, and you can just see some examples of what's going on in here with rounding. Okay, and examples of square root and max min, stuff like that. I don't want to talk so much about this slide, but I do the next one. This is, we're talking about random numbers. So generating random numbers. And what you can see here is that we're using this, we're going to create this instance of number or a random number. And once we create that based on using the random method, then we can now go and use these different methods inside the random class. Okay, so what does this one say here? It says number.next, an integer which is greater than or equal to 0 and less than an int32 dot max value. Okay, so that's a little bit out there in terms of being a total expert on different data types. Okay, but general convention here is we're looking at this and saying, okay, what's with this one? Next, we're saying that my value is going to be greater than 0 and less than 101. So give me a value that is between 0 and 101, or actually really 100, but I want a random number. So if you're doing some sort of dice roll exercise, this would be a really good case, right? So you're saying dice 1, I want, so in this one, this is the example right here, right? So I've got two parameters that I need to pass in, or two arguments, and it's really, you're saying, what's the minimum, what's the maximum? And then when I want to use this, I'm saying dice 1 between 1 and 7. And the reason it's, less than 7 is because a dice only has up to the number 6. So this is how you would want to use this. Just tell it, this is the range of numbers that I want to see on this random roll of dice. Okay, so that's kind of how you use this one. Okay, strings. We're going to spend a little bit more time on strings than maybe normally I would. But, a couple of things to note here. When you initialize a string, you could put the full text in. And the big thing is the brackets. Okay, that's the important distinction between other variables and strings. Okay, you can see down here, this double doesn't have quotations, right? If you have an empty string value, you haven't initialized your very first instance of message2 yet. You don't know what you want to say in there. You know that in the future you are gonna have something put in there. For now, you can just put two brackets, or in the next case, you can go with null. I strongly suggest that you kind of go with this this scenario here instead of null. It's just plays a little trick in your mind where you look at it and say, okay, there's a string there. That data type instantly I know is a string. Okay, so this is a lowercase, obviously, because we're focusing on C#, but first name, last name, and then, this idea of concatenation. And the important thing with the concatenation is that you're taking these names here and you're not putting in any quotation marks in here. Okay, the quotations have all been handled at this point and then assigned. So first name's value is now Bob. So the quotations are taken care of. But when you're doing this concatenating, you need these plus signs. But don't forget, in order to get an output of Bob space Smith, it is the space between the concatenated words that definitely needs to have that quotation. And there's a space in here. Okay, so you have to put that in there to get this output. Otherwise, this gets moved right over beside the B. Okay. And you can see sort of an example here where I know what price is. It's $14.95, but you're worried about like the symbol, how to represent money. Well, you can do that by actually putting it all into a string. Then I concatenate the actual value, and then I just add the variable name to this. And that's how I get this output. Okay. So in this slide, we're going to talk about the word append. And really, the only thing that I want to say about this is that when we append something, what we're really saying is add it to the end. Okay, so that's really all that means, the word append in the context of this. We're saying take what we have already and add it to the end of what we're doing. Okay, and you can see the examples on this slide here. You can see that we have first name here with, we've got first name, last name, and then we have name. And what we're trying to do is combine it all into one. We eventually want to get to Bob Smith. But in this particular line here, this one, what I'm saying is append. So I've got name here and name here, and I'm saying add to the end of it the last name. And so this is just like we can do with math, where we can do the equation on the right-hand side and then assign it to the left side. But, on the left side, it's already got the same named variable. It's the same as saying like A equals A plus 1. It's really hard to draw with my mouse. Sorry. Okay, it's the same sort of thing that we're doing. We're just taking it and adding it to the end of what we've already got. And down here you can see, just like we do with mathematical operations, you can append a string in the same exact way with the plus equals operators. Okay, so that's all I really wanted to show on that slide. In this slide, this is the escape sequences. Okay, so what's really important about this one is really the most important one, I think, is the new line. Okay, and this is the same in the C language, I think Java and C++ for sure. We use this new line escape sequence. This is just to move what you're doing down to the next line when you print out to the screen. Okay, and there's the tab. So these escape sequences are probably the most common and they're pretty important. And here's this example of it right here. We're adding the escape sequence. We're concatenating in the escape sequence to what we want, because we have really this block of code that we want to display, but then we want it not all on one long line way out here. We want to use the escape sequence, the \n or new line, to push this down to the next line. So that's really why we're using it. Okay. Okay, so this slide is important for a couple of key reasons. And first and foremost, it is this issue right here. And I'm not going to get too much into the idea of what is a structure. Okay, we'll leave that for another time maybe. But so far when we've been kind of looking at examples, we have integers. These are the actual data type. So if I say int age equals 10. Okay, the 10 in that equation is an integer data type. Okay, and so those are, relatively simple primitive data types. And in the last video, I spoke about classes and how we instantiate a class. Okay, so like I said, these are structures right now, but there's this other issue in the .NET framework and in C#, and it's classes. And I talked about that in the last video. So it's important to understand that this is a reference type. So when we use a string or an object, there's the potential that we're calling the string class, okay, or an object type. So don't worry so much about the object right now, but just focus in on string. So what it is implying is that when we call a string or we use a string, we're actually referring to the string object. And whatever we do after that, we're instantiating a version of a string object, and then we're using that as its own separate variable. And so we'll have to get in and look at some examples of that in the code coming up. But before we do that, I want to talk about this data type conversion. Okay, so this is going to be really important information that we talk about right now. And so I think we did last time, we realized that every single time in our desktop application, a user types in information. They're actually typing in a string. Okay. And you can see from the last video, the example, we took the input from the user as a string, and then we converted it to a different data type. And then to get the result, we ended up having to reconvert that result back into a string. So every time someone types values into our application in a text box, it's a string. Okay, so it's got to be converted. And so I want to spend a few minutes, continuing to talk about this. And I think we've seen this one in the last video where we did that conversion in our application. I think it was maybe a decimal number that we had. We did a 2 decimal. So we went from 2 string, 2 decimal. And then when we wanted to see the output, we went back to a 2 string because the output we want to read is also a string. But if we look at this parsing of a string, so this is a static method that converts the specified string to an equivalent data value. Okay, if the string can't be converted, if it can't be converted, an exception occurs. So we're going to come back to this because it's going to be very important. And then we have this one called a TryParse. And you can see that there is 2 parameters in this. There's the string that you're passing in, and then there's the result. And so this TryParse is a static method that converts the specified string to an equivalent data value and stores it in the result variable. Okay, so we've got the conversion that gets stored in the result variable. And it returns a true value if the string is converted. Otherwise, it returns a false value. Okay. So, we've got all these different methods that we can use. Okay. And I think it might have been last week that we did either 2 double or 2 decimal or 2 double, one of the two. But all it's doing is exactly how it sounds. It's just missing the word convert, and I'm not going to spell it because it's painful, but convert to decimal, convert to double, convert to int32, which is an int data type. That's what it's doing. But this one here is the one that we'll see very often. Okay, and you see the difference here. It's saying convert to a data type, a bool data type, data type, data type, data type. But this one is saying convert the value to a string object. Okay, and that's the important thing there. So that's the big distinction here. Okay, so let's continue on and look at these sort of 3 statements. I've got 2 string, Okay, so we've got this this number here. It's a decimal number of sales, and then we've got this string, sales string, and we're saying take this and then convert it to a string, because right now it's currently a decimal. Okay, and then in this particular case, this parse, we're saying, okay, sales is a decimal dot parse. So this is the class calling a method parse and saying, okay, sales string, which is this one here. And then finally, this TryParse. Now, this one is kind of about dealing with true false. Is the result what we really want? So if you're familiar with a try and a catch, kind of look at this in the same sort of way. So try to do this and hopefully you get a true result. If not, you're going to get a false result. And you're kind of specifying this sort of output where it's going to store the true or the false. Okay. So we're gonna see this soon. Okay, this conversion statements that use the convert class. Okay, and you know this is really what we're talking about here. This convert to. All right, and this is sort of one way, another extension way of doing this. Okay, we can say convert to decimal, and you can see where I was trying to draw this. Okay, and this is really what I was getting at. In this case, we're adding a decimal. So if you look here, we're saying convert dot to decimal. And this is how we do that stuff. And then look at here again, we're using the dot operator inside our argument. Okay, so here is some of the, this is sort of formatting. This relates obviously to string formatting and stuff like that. So we've got two optional codes, right? And it looks like it takes the first number, so what we're looking for. But the ones that are going to be important to us in formatting terms are probably these two right here. Okay, currency and percent. So just if you're trying to think, just go with the first letter. And so here we can use this if we want to format the monthly amount. Okay, so what we're saying is take the amount, convert it to a string here, and then put the C in quotations. And what that C is going to do is it's actually going to give us the $sign. And then you see the P1 will give us the percentage. Okay, and you know, this N0, okay, converts this into a number. So when we look at the comma, that's what it puts in there. Okay, and then we're looking at some formatting here with that dot. Okay, and that's what this is really all about. So really quickly, again, this number really gives us a comma in between. Okay, so that's what that is. And then the F is saying put the period in probably the third decimal place. Okay. Yeah, so this is another way of doing that. And I post the PowerPoints for this. So if we go back to the original example from the last video, and we talk about scope, the best way I think to explain how scope really works, just in case you may not know, I don't know. Let me pick a different color. It really comes down to the brackets, the way they use these curly brackets or braces, the way you want to use it. Okay, so anything that's inside brackets, whatever is inside here, you can see in the yellow, that is the scope. Okay, so it's another way of putting this big giant box around something. That defines its scope. And you notice here that this decimal number of invoices in total of invoices, they don't have these brackets to protect them. But you look down here at this click method, and you see these brackets here. So what that says is I've got this entire box around my code. And then one more time, this box. This is the scope. And so let's say this, whatever happens inside the box stays in the box, okay? And this is really, the best way that I could illustrate scope. You may be already familiar with scope, but notice in this particular case here is that, where's my little pointer thing? In this case, there's nothing to protect this. This value is accessible everywhere. And so that's really what we're talking about when we look at a class scope or a variable scope. And you can see that there are some exceptions, right? Because I have total of invoices there on the outside of that boundary. But how is it that this can be seen inside that box? Okay. And that really has to do with, scope. That's what we're talking about with scope. Because these have no protection, think of inside the box, there's a window. Okay. The window can see out and get stuff. Okay. But, or a door, you can use the example. This can get actually in. Okay. So there's sort of access issues that are at play here that we haven't fully explored, but that's okay. But it's just so you know that the scope is defined usually by these brackets. It's also, another name is a code block of what's inside those brackets. But notice that you can have access to what's on the outside. Okay, so number of invoices is also present right here. Okay, so really we're talking about moving in and out of scope here. Now you can see down here, again, because these are global, and we've referred to those as global variables. Okay, number of invoices, total of invoices. Okay, these are what we refer to as global variables that can be seen anywhere. Okay, and then anything inside this function, we call this a local. So subtotal is local to just the click function. Okay, so this is another local variable. So that's really the difference between local and global variables. Okay, so on the outside of this, I cannot see subtotal. Okay, so I couldn't now go outside of that block and try and use subtotal. I would be prevented because it would be outside of the local scope of the click method. Okay, so because this is global, I can see it anywhere. But because this is local, the only place I can see it is what happens inside the block stays in the block, okay? And really, we do refer to something called the lifetime, because when this method gets executed and all of this calculation here all happens, the moment that it is done happening and we are no longer inside of that code block, then the lifetime of these variables ceases. They're no longer there. Okay, they die. They have a lifetime that only lasts for as long as the compiler is dealing with that function. Okay, but these ones, they have a lifetime that lasts until you turn off the entire application. Okay, so that's what we refer to as lifetime. These will stay available and open throughout the application while it's being turned on. These will be created and destroyed as soon as this function call is no longer required, but your application is still running. I think what I'd like to do now is just stop talking and get over and start doing some coding. So from last week's video, we had this particular application. And I think what I want to do is just now go through, modify last week's invoice total to what you're seeing here on the screen. Okay, and the code is all in the, it's all in the slides actually. So even here, what I'm going to do is basically implement this. Okay, and the first place that I'm going to actually start is I'm going to go back into my form and I'm going to update my form. Okay, because you can see here that I have to add a label, text boxes, 3 text boxes, 3 labels, and I've got to actually add in another button. So why don't we go in and do that? So I'm back in Visual Studio in last week's form. And what I'm going to do is give myself a little bit of extra space. Okay. And the first thing I need is a label. Okay. So I'm going to put my label in first. And my first label, don't forget, I need to go in and name it. Okay. But I'm going to build it out first, and then I'm going to go in and start relabeling everything. Okay. It's just so that it keeps in my mind what hasn't been done. So I'm going to need 3 labels, and it turns out I'm going to need another button right here in the middle. And let me just kind of space things out a little. And then I need 3 text boxes. Okay. And so I could technically, just copy paste those 2. I could copy and then paste 2 text boxes. That's just a quicker way of probably doing this. All right. But if you do copy and paste that, just make sure that, as you tab, it's going to have an effect on the way you tab things in the future. Okay. And what I say about that is, if you look here, this box here has a tab index of 15. And this one is 16, and then this one is 17. Okay, so just remember to be aware of what you're doing with that. And so if I look at my first label, it's going to, I need a new name, and the actual text is going to say number of invoices. That's all, and I'll put a colon in there. Okay, so I've got that on my form, and in fact, I'm going to move everything over because I have plenty of screen space, and I don't want it to be cramped. And I'll worry about sort of formatting really later. Put that there, and then my next one is going to be labeled, and I'll stick to this so that it's nice and neat. Okay, because when I go to my name, I need to remember that I have to be very clean with my naming conventions, and to make sure that I know the difference between the actual label's name and the text that it prints to the screen. Okay, so this is going to be in the name, LBL, and it'll be camel case, number of invoices, and I'm trying not to put spaces in there. Okay, and I got to make sure that I don't put any spaces. Okay, so for now that's good enough. I'm going to go to my next label, and this will be LBL, and we'll call this one total of invoices. Okay, and then let's go back down to the text. And this is going to say total of invoices. And we'll put a colon in there. So we change that label. And then finally, this one's going to be invoice average. So we'll go back up to my name and do LBL and invoice average, colon. Okay, and now let's go back. Oh, I can't put the colon in there. That was wrong. LBL invoice, because I'm getting confused between the label and the name. So invoice average. Okay, and then I'll go back down to the label, or the text, sorry, and this is going to be invoice space average with a colon. Okay, so it's really, really vital that we end up doing that properly. Okay, and we can really worry about formatting a little bit after as well. You've got these helpful colored lines that help you align all your text in your boxes and all that stuff. So now let's go back to the actual box. And you can see that the name, it's text box, okay? And then down here, there's no label that I need to update for this. It's just strictly text box. So this is going to be TXT number of invoices. Okay, and remember, this is a vital thing because this is the thing that's going to allow us when we get to the code portion of this to reference this. So I have to be clear about what I'm doing. So text total of invoices. Okay, and then finally, this one is going to be TXT invoice average. Okay, and then I've got this button. I have this this button here, and what do I want to call the button? I'm gonna call this one BTN for button, and then clear totals. Okay, so that's what I want to do, but this one does have an actual name on it. And all we're gonna call this one is, I believe we're just gonna call it clear totals. Okay. And so that's all we have to kind of do for that right now at the moment, but we'll come back to it because there's probably just some formatting things that we want to change. Okay. And I suppose right away when I look at this, what I if I looked back at the example, I know that this should be a read only. So I'll set that text box to a true. This one is read only. And if I have both of them to do as read only, I can highlight the two of them and then go to here and change them both to true. Okay, so it's a little bit more efficient. And I'm going to go ahead and I'm going to save all that. All right, so the next thing I want to do is go back into the actual code. Now, if you're wondering how to get there, just for now, I'm going to say do it like this, just for now. And this is to show kind of a point. All of these buttons are tied to a specific file. So if I go to my Solution Explorer, you may not know which one it is, but so just for now, until I'll show you later how to get there. Just for now, all you got to do is click on one of these buttons. Okay, that's all you have to do to get to that file, but keep something in mind. We're trying to create the functionality for this, okay? So in our code, the functionality for calculate and for exist is already in existence, but not clear totals. We don't have a function or a method of any kind for that one yet. So what I'm going to do is, because I know that this is really what I want to build. Now that I have it, I'm going to double click on that, and you can see here it puts it right below our exit button. Okay, so the method that we're going to create is now below our exit button. So it now gives us all of the method outline to do the calculations inside this clear total button. Okay, and so I talked about global scope, and it's because there are some things we have to initialize first and foremost in our global scope. And the place we do that is right after our we're initializing our form. Okay, so we have to put it into this place because this part is really what, when we run this, and let's go ahead and save this. We'll do a save all and then just do a debug start without build. Okay, and I think the last time, we had this set to being in the center of the screen, and you can see I can click on this thing and nothing happens, right? Because we haven't made that functionality yet, but we're going to. But I can exit that. And when we exited it, what happened was it called this exit button in this close function, and it executed that. So really, before we can sort of start getting into this method down here, there's a couple of global variables that we have to put in place. Okay, and these global variables are really this, we've got an integer and we're going to count the number of invoices. So number of invoices. And we're going to initialize that to 0. Okay, and let's not forget the semicolon at the end. So that's the first one. And then we need a decimal. And this is going to be total of invoices. Okay, and this one here is going to be a 0M. Okay, and we'll set that one. And then finally another decimal. And this one is going to be invoice averages, or average. And this will be a 0 as well, a 0M semicolon. And, you know, it helps if you spell things properly. Okay, and now I'll save that there. Okay. So as an option, what I want to do is just kind of leave the whole logic around this particular piece. Okay, and really when we go back to the design, what are we trying to get at? Is we're trying to sort of track the number of invoices, the total of the invoices, the total value of the invoices. And then in here, we're trying to get the average value of all of them. Okay, so let's go in here and start doing some modifications. So really, I want to say that on what happens on this side is kind of an accumulation of the different invoices that happens on that side. Okay, so let's go into the code and have a look at that. So I'm going to go into my discount amount, and I'm going to actually put this into a method. And you'll see what I'm doing, because I want to call the math class and use the round function. So this is that static class that I was talking about, static class of math dot. And now you can see when I do this, it gives me the options for calling that. But my round function or method, you can see that I don't know if you can see it on the screen, but it says here I have 7 overloads. It means there is 7 different combinations of this round method, and they're all called round, but really it means the difference in the parameter list. So in this case, I'm going to say round to 2 decimal places. Okay, and you can see what it says. Rounds a decimal value to a specific number of fractional digits. So it's an integer and it's 2 decimals. Okay, so I make that change there. And I think I'll leave invoice total. I'll save that. And what else do I want to go in there and change? And I just actually realized that I'm actually missing missing some stuff here. And I'm missing a label, okay? And I'm missing a text box. And this is sort of part of the exercise, and I kind of glazed over it. So I'm going to put this back in here, and I'll move it down. And this one is going to be, this label is going to say, let me click on it. I've got them both. So this label is going to be, I think we'll say txt enter subtotal. Okay, and that's what that one will be, enter subtotal. And the label that I want to give it is going to be, or the text on there is going to say enter subtotal with the colon. So that's what I want that to say, and I'll line that up a little better. There. So I've got that, and I need to do this text box as well. And this is going to be txt, and it should say enter subtotal. Subtotal. Okay, and that's fine. it didn't like the way I typed that. TXT enter subtotal. Okay, it's not valid. What's going on? And the reason is it says that my name txt enter subtotal is already in use by another component. Okay, so what that tells me is over here, I should have had this as a label and I made it a text box. So let me highlight that because I don't want to respell it. So copy, and I'm going to change this to LBL. Okay, and then now I can go to here and in fact change that. So we're good there. And one of the things I need to do is go back to subtotal and change it to a read only. Okay, so down here under R, I'll change that to a true. And you can see that that gets shaded out. And these look absolutely terrible the way they are, minus this one. So I'll move those down a little bit as well. Maybe I'll move all this into a better position. Formatting isn't totally vital at this point. You can clean it up later. So now I need to go back and do an update to this because the new text box that I put in, I have to now sort of account for that, right? And let me actually go to the top here because I'm in a situation where we've got the enter subtotal and we have enter total. And so because of that issue that I just didn't notice, I've got to go back up here and make an actual change. So when I look at my decimal subtotal convert to decimal, what I want to do is now change this text to say enter subtotal. Okay, and that is going to be a text box as well. Okay, so now the next thing is my discount percent, I can actually change that to just decimal to 5. I'm just going to change that. All right, and it doesn't look like I need to keep this logic. So what I'm going to do for now, instead of delete it, I'm just going to comment it all out. And I'll keep it in case I need it in the future. Okay, and we've gone in and we've already done sort of this rounding operation. I've got my discount percent. I'm good. My this is fine the way this is, and my invoice total looks fine to me. So I'm good there. But now do I need to do some changes to this sort of subtotal? So the subtotal, what I have to do now is I want to change the sort of formatting of my subtotal. So you can see there subtotal, and I'm going to change this to a ToString, and inside there it's going to just be set to a C. Okay, and put my semicolon in there, and then I need to go and actually set that to the text itself. So this is going to be txt sub, and does it actually pop up? Let me see. Txt, let's put the equal sign in there. Let's see. Start over. Txt subtotal dot text. Okay, and so really we've just made that little minor change there now. I think this is, the rest of this is fine, but now I've got a couple of things, right? So we talked about incrementing a little bit. My number of invoices is going to increment. Okay, and so is my invoice total. So the value of all my invoices is going to increment. And so what I want to do here, because when I do the calculation, it's going to automatically update that piece. So what I need to do is say number, and you can see it, number of invoices, and I just have to increment it. So I just have to do plus plus. Okay, that's all I've got to do on that line. And so when I start off as my first invoice and then I add another invoice, it's just going to accumulate by 1 each time. And so here now I have to, in order to increment my total of invoices, this is going to be plus equals, and then my invoice total. So where is invoice total? Is right there. And that's all I got to do. And what that's going to do is take my total amount for each new invoice, and it's going to add the accumulated total, and it's going to put it in that box and display it. And then lastly for this section is I have to come up with the average. What's the average of all of my my invoices? So I've got my invoice average, and this I'm going to set to this calculation, which is just my total of invoices divided by my number of invoices. Okay, that's all that is. So it's basically saying my number of invoices and my average or my total invoice value, and pump out an average across all my invoices. That's all I have to do for that one. So I'm going to go ahead and save that. I'll save all. And let's go test it out and see if we have any errors in this. So let's go do start without debugging. Okay, and you can see that the window actually went somewhere else. So I'm just testing this out. Let's say 500, and we'll calculate. And you can see it's not yet populating over there, but everything else here seems to be working relatively okay. Okay, and I'll exit that. So I'm happy, I'm satisfied there that I don't have any real obvious bugs, because I could go to here to my error list on the bottom, but you know, sometimes it may not show me everything that I want to know. So every once in a while, it's a good idea just to save it and then test it out. Okay, so we're still not done inside this particular method. We still have to now do conversions. Okay, because we've got the calculation going, but how do we convert it into its current state into an output string? Okay, so like we did before on this one, we did all the calculation, but then in order to have it read out to our application to be able to show it inside these boxes, now we have to again go and convert it all into strings. So let's go ahead and do that now. So this is txt number of invoices. Okay, dot text, and you know, it's just really number of invoices dot ToString, and that's a method call. That's it. Okay, and the next one is going to be txt total of invoices is what I'm looking for. So I've got total of invoices dot text, and that is going to be initialized by total of invoices dot ToString. Okay, ToString, and we'll put the formatting to a C. Okay, inside there. We've got a little bit more. So txt, and this one is my invoice average. Okay, right there, dot text, and that's initialized by invoice average dot ToString. And again, this one will also be as a currency. All right, so we've got that formatting taken care of now. So one more thing I want to do is I want to set my text in my enter string to an empty string. Okay, so remember here, we are going to have the user type in some text. And so initially for the first time, we want it to be set to kind of a null value. And the way we're going to do that is just txt, and it's enter subtotal. And the text here is just going to be, because it's a string, right? We're going to be receiving a string. We're just going to put this in here like that. Now, another way to do it, I think, is just doing null. Okay, but I'm not going to do it in that particular case, because when I visually look at that, it's not really what I'm getting. it's not intuitive right from the very beginning of what's going on. Now, the next thing is this txt enter subtotal, and it's going to be this. I want it to focus on that cell, on that text box. So I'm going to call the focus method. Okay. And what that's going to do is when I run this, this is going to be what shows up, what, like the first number, as soon as I start typing that, we're focusing in on that box. Okay. So let's save this. I'm going to do a build. Okay. Build the solution. And it looks like I have no failures, no errors, which is great. And so let's go ahead and run this and see what happens. So I'm just going to type in 500. Okay. So you can see what's going on. My invoice total here is being populated, and it's counting that is my first invoice. So let's do another invoice, and we're going to say this time 1,000. We'll try to keep the numbers. Actually, let's go, 1,000. And then we're going to say calculate. And you can see that the totals, maybe there's something, is there something off? Because my total invoices should have been somewhere around, no, I think that's right. Because we had this $1,500 deduction, right? So really I think we're doing fine. Let's do one more. Let's do 1,500 and calculate that. Okay, so we're actually doing okay here. Does clear totals do anything? Can we clear the totals? And the answer is no, because we haven't actually gone in and built that functionality yet. So let's go back over to here. And we know that we have clear totals already set up. But we've got to be able to reinitialize all that stuff back to 0. So we'll say number of invoices. We will initialize that again back to 0, and we use M. And this will be total of invoices. Again, will be 0, and we'll set that to M. Sorry, this should not be an M here. Okay, just the numeric value for the sort of financial pieces. And then my invoice, I'm looking for invoice totals. Invoice average, sorry, it's right there. And I will set that one to 0M. Give me some room. And now I have to deal with all the text boxes. So really this is just txt, and I'll call each and every one of those. So it'll be number of invoices dot text, and set those to those empty strings. Okay, so that's done. And then finally, the last thing is I'll reset this focus, txt, and it'll be enter subtotal dot focus. Okay, and that's it. That's all I've got to do for this particular example. Save that. I'll do a quick build. And now, once the build is done, I can do a run. And here we are. Let's see what happens. Let's do 100. Calculate. It does it. And you can see the subtotal now, because our discount is 25%. That's our subtotal. That's our first invoice, total of invoice. Okay, and so far the average is 75. Let's do another, let's clear this, clear the totals. Okay, what happens when we calculate? We get this error. We get this exception handle. And that's because we're not there yet with exception handling. Okay, so far so good on what we're doing. It's all working, and we just made some simple modifications. So let's move on. So I want to spend a very, very brief amount of time talking about methods, or calling methods. And, in C#, there's differences between maybe, let's say, for example, C++. Okay, and one of the differences that I want to point out is this, that, we have our return type for our method. We have our method name, and we have our parameter list that goes in here. But what's interesting about C# is that at the beginning of every method, we actually specify whether it is public or private, which is kind of in contrast to maybe the way you call your own class, or you define your own class in maybe other languages. So for example, in C++, you would define in the class which variables are public, and you would define the methods or the functions in that to be private inside the class. Okay, so that you don't actually have to go out and declare that your methods are public or private. But in the same sort of sense here with C#, when we're using them in the way that we've been using them, if you look at the way we've been using it in here, this click method, okay, as soon as it automatically made that, it gives the keyword private, okay, because it's not part of a class that we're actually defining ourselves. Okay, so when we use these objects, because don't forget that the button itself is an object that has a function built into it for the clicking that handles that event. And so when this happens, this keyword private is getting used up front. Okay, and so we have that situation here as well, public or private, when we're calling our events. Okay, so inside the code block or the scope of that, we do all of our code. Okay, so that's pretty straightforward. And to be clear, the difference between this thing here, this parameter list and argument list, is the parameter is what we define when we write the function. The argument is what gets passed into it after, when we're calling the function itself. Okay, so you can see in this particular case, what we're having is this is a private function. We've got the return type of the function itself. And that's something really important to understand, is that this return type is actually meant to be for this. Okay, this is the type that we're talking about. So we do this whole entire calculation and we produce this value here. So it returns some sort of a value. Well, what is the type to that? And this is why up here we actually we specify the type that it's going to return back to us. Now, not all methods actually have a return value. Okay, sometimes they don't. Okay, and at some point we're going to talk about setters and getters, but a getter has a return value, and you can see the word here, get, but a set doesn't actually have that. But we still have to consider what we're setting, which return or what data type we're going to set. Okay, and so when we look at this particular method right here, we've got three parameters that we're passing in. We've got this one here, and these are decimal types. And notice we specify the decimal type in this way. And then we've got this third parameter. Okay, but when we actually go and call this function later, these will become the three arguments of it. Okay, and so you can see that we are specifying our decimal and as a return data type for future value. Okay, so this function is really meant to return one thing, one value. Okay, so all of this calculation, depending on conditions, is just really meant to return one single value. Okay, so if we want to call it, let's say inside of an object, and I talked about this last time, but if I want to call an object, if I want to call a method for the current object, this is where I'm using this keyword this. Okay, so we're saying this dot disable button. Okay, this dot get discount %. All right, And so you have to know when you're going to call or use this keyword. And it's typically done when you're using or you're defining your own class or you're using a class. Okay, that kind of syntax is typically confined to inside of a class. Okay, so if you were looking inside your class, you'd say this dot disable buttons, and it would call a method that is available or inside the scope of a class. And so I want to look at this particular library method here. Okay, and what's happening here is you've got this very special one here, this show method. Okay, and what we want to return here is we're calling this message box, and we're using the dot operator, and then we're saying, okay, show this message. Okay, and you can see that the first parameter is a string message, and then there's this string caption. But what's important is this show is a special kind of a function that does outputs to our actual screen. Okay. So sometimes we perform our user executes a functionality that they may or may not want to do. And sometimes you got to prompt them to ask them if they're sure about this, right? So if in this particular case, I type in 100 and I say, do the calculation, and then I say, clear the total. Okay, it disappears and there was no prompting. And so one of the things we can actually do is add this message. And you know, the way we do this, and there's a reason why I'm bringing this up right now. And for now, what we're going to do is just call message box, not message box buttons. So I'll do message box, and then I call this show method. Okay. And inside there, you can see I just need to put my semicolon in there. And so I'm getting an issue here with my show method. But one thing's for sure is I do need a minimum of a parameter. Okay, so what I can do is I can look at this. I'm in my message box class. Okay, and then you can see all of these different show methods that are in there. If I go back to here, you can see there's a sign that says plus 20 overloads. So I can have 20 different combinations of parameter lists, but they're all called show. And sometimes we refer to that as function overloading, where it's one name, but we have 20 variations of it. And you can see all the different things that are going on in here. Okay, so I can have that. And so when I go back to here and I'll just, I'll save this and I'll do a test of this, type in 100, calculate, clear totals, and now I get the message box. It prompts me, do you really want to do this? So when I hit OK, you know, it does disappear. Now, keep in mind, there's more to this because as I did this, 100, I'll put 1,000 and I do a calculate. In this particular case, I hit the clear button, but notice it's there, but I hit the clear and it actually did clear it before I said okay. Okay, so there's different combinations of the way you can use this particular message box by calling the show function. Okay, and so when you look at these, you can go through all of the different ones. And in some cases, there are buttons, okay, where it'll give you a yes or a no. So the very first one that I called was just a single parameter with a string, right? This text to it. And there's, you know, you can go through and read about all of them and find out which one you actually do want to go and use. Okay, but you can see that there's a return type here, one of the dialog result values. Okay, and that's really what this is talking about. This is this return type that it wants, a dialog result. Okay, so let's move on. And all I've done here is I've just added this little thing that says, hi, Tom. It's another, I'm passing in another argument, which is just another string here. Okay, so when you run this, and I just hit the clear totals, so I don't have to input, but you see it says right here, this is the caption in the window. Okay, and are you sure you want to clear these? Yes. Okay, but that's not the fully functional thing, so just keep that in mind. Next thing I want to show you about, but I don't necessarily want to use it yet. If I go into my form and in the design view and I click on this, there's this little icon over here, and it is called the event icon. Okay, and these are really different events. Okay, so you can see this one here, this click. Okay, and in the future, we're going to come back and we'll be able to actually modify those. We'll actually be able to use those, this sort of functionality. And this is another icon called the properties page, but for now, don't worry about it. We'll come back to it. Okay, and this is just your normal properties. And obviously this is alphabetical and then categories. But for now, just understand that it is there. And these are all events that the user is going to do. So mouse down, mouse up, mouse move, different events that your application is going to be listening for if you program it to do so. Okay, there's another one, resize. Okay, so there are events in here that we can wire up ourselves. So now I'd like to spend a little bit of time talking about exceptions. Okay, and you know, to understand what's going on with an exception, sometimes your user is going to put in something that you really haven't accounted for. So it's going to say, hey, wait a minute, there's something unusual I don't know how to handle. There's an exception to my rules. So what do I do about that? And so we're going to spend a little bit of time talking about it. Okay, and in this particular case, you're seeing exception unhandled. And so we have to kind of have some sort of method to handle a little bit of the unknown. Okay, so if you look at the 5 common exceptions, you know, you've got a format exception, an arithmetic exception, an overflow exception, or a divide by 0. Okay, so these are the 5 kind of common ones that we have. Your formatting is wrong, your math is wrong, maybe your array is way over, you've screwed something up badly in an array. Okay, and so you're getting an exception there. Or you're trying to literally take something in your math and divide it by 0, and you're getting this exception. So, you know, there are these methods here that can often throw your exceptions. And these are the typical ones here. Okay, so you're converting your classes within your methods to decimals, to ints, and you're parsing. So the parsing is one where you could definitely see, you know, exceptions. Okay, and it'll be an overflow exception or a formatting. Typically, it'll be one of the two. Okay, so, you know, we talked a little bit about this as well. You know, and we're not going to get too deep into it again, but we kind of went through this one time already. And so those kinds of things, these message boxes, it's good to know that we have them, because now when we do this thing called a try catch, and if you've done other languages before, you've probably done a try and a catch. Okay, so we're going to just do a real quick example of try catch. Well, maybe I don't even have to. You can see it here up on your screen, a try and a catch. And I think there's a short thing that we can do to build out the template to this in our code, so we don't have to type out the try and the catch and all the brackets. And we'll look at that. But if you see what's going on here, we've got this try all of this this code here up front. We're saying, you know, try to do all this block of code. And if you get some sort of unexpected result from my user, they've kind of gone outside of this, then catch it and then output a message. Okay, and the message is, please enter a valid number for the subtotal field. So your user has done something, A, that you anticipated because you've done a try catch, or B, something you haven't anticipated. So you've got to kind of come up with a way to handle it. And that's really what the point of that is. Okay, so we should probably, have a look at that inside our applications. Okay. But, here's this example of what this kind of code looked like, right? Try to do this stuff. And you can see that there's a subtotal box here. And the user has put in XX. Okay, and then the expectation is that you try to do a mathematical calculation with two X's, right? And this is what the result is going to be. Send out this message box that says, enter something valid. Okay. And we've got sort of some syntax of what's going on, what's involved in this. And if we look at the top here, the first block is your try. Try to do this. And then the catch is really about your exception class and the exception name. Okay, and so different properties for the exceptions. Okay, we've got this method gets a message that briefly describes the current exception, or gets a string that lists the methods that were called before the exception occurred. So that's stack tracing. That's more when we get really into the debugging piece of this, okay? And common methods for all exceptions is this get type. So when we look at this, we've got this try catch statement that accesses the exception. And we're saying, okay, go ahead, do all of that. And then with this exception, and you can see here, we've got this syntax in here. Okay, with our try and our catch. Because in the previous slide, we didn't actually pass in a parameter here, right? All we said was put out this message in this particular case. But now what we really want to be doing is saying, okay, I want to trace what's going on in that. If it is not working, then let's trace that. Okay. And you can see here, we've got this get type or this stack trace. So this is really the big difference between the two things that are going on. And so we could end up getting with our stack tracing and stuff like that, we can get messages that look like this. Okay, so you can see right here, input string was not in a correct format. Okay, and after that, it gets a lot more complicated. And you can see here, we've got, it always starts with our try. Okay, and then we go to our catch, and we're looking at sort of three different options here. Most specific exception, next most specific, last specific. Okay, and then finally a statement that you can add at the end there. So if we look at this example here, right, we're saying try all of this code up here. And then we want to catch this format exception. Okay, and as a result, if we get one of those, then put out this message. Then we say want to try this overflow exception. And if that's the case, put out this message. And then, finally in this particular case, we're saying we've got this here exception finally at the end. Now, do this sort of block of code. And then the last thing we can do is this finally. Okay, and then, create have a function this performance or perform cleanup. Okay, so this code runs whether or not an exception occurs. All right, so that's kind of the rough outline of what's happening inside of our code. In a sense, it's like a debugging tool meant almost like an if-else statement. Okay, so try this. If it works, great. Try that. If not, or else. Catch this. Okay. And so, we can kind of look at this, like I said, with putting it into our conditional loops too, right? Where we can say, if our monthly investment is actually less than or equal to 0, so it ends up being a negative number, we want to throw this new exception. This monthly investment must be greater than 0. Okay. If your monthly interest rate is less than or equal to 0, we want to throw this new exception. Interest rate must be greater than 0. Okay, so there's combinations of the ways we can do these things. So I want to spend a minute here looking at this as well. So we can code that throws an exception for testing. Okay, and this one here, this get type. Okay, this is it gets the type of the current exception that's being thrown. Okay, so that's kind of an important thing that we would want to see here. Okay, and then if we have some stack tracing, again, we can go in and write these things to do our own little bit of testing if we need to. Okay, so that's kind of an important thing to be able to do. But there are other debugging tools, but this one is kind of the sort of quick and dirty way of doing it without having to go through and do like breakpoints and stuff like that within the IDE debugging tools. And for clarity's sake, I want to talk about this right here. This is the name. So what's happening is I'm calling my this is let's think of this as a parameter that I'm passing in here, okay? And it's of a type exception, and we're just going to call it EX, short for exception. And then you can see here within my code, I'm using EX or exception with my dot operator to go and call my get type. Okay, so this is how we employ that when we want to do these tests. Okay, it's one way of doing it. Now, what does it really mean to catch an exception and then throw an exception? And you can see this example right here, this syntax for throwing a new exception. Okay, so you've caught an exception, great, or you want to throw one. And when you do this, you keep in mind you have to use this keyword new. Okay, it's part of the syntax to it. So when a method encounters a situation where it isn't able to complete its task, you throw an exception. When you want to generate an exception to test an exception handler, when you want to catch the exception, perform some processing, and then throw the exception again. Okay, so this one here. So, look at what's happening here. Now, a method that throws an exception when an exceptional condition occurs. Okay, and so you see what's happening here right off the bat. In my program, I'm saying this right here, throw new exception. And all I'm simply doing is basically putting it inside that bracket, and it's just putting out a string. And in this particular case, I'm saying throw a new exception again, and this has to do with that interest rate. So when I throw an exception, I have to create a new object for it. And that's why we use this keyword new. So when we throw one for the first time, we've got to use new. Okay. And you can see that we've done it in this example here as well. Okay. So I'm saying try this, but throw a new exception in this particular case. And you can see it right there. Throw new exception. Okay, and then when we're catching, it's down in the catch block that we created this one here to use it. Okay, so you have to understand that there is a difference between the try and the catch blocks, and that the try, we're throwing this exception here, and down here we're actually, we're going to use it in order to do some getting the types or getting the stack traces, okay? So there is a little slight difference in there. So there's this thing that you can actually do in here. What I'm going to try and do is put this into a try catch. And it's not going to be a full sort of try catch. It's just for demonstration on how to do this easily. So one of the things is I can start typing the word try, and you can see here I get this little message that shows up, and I just do TR, and then if I hit tab twice, what happens is it actually gives me all of my code, right? So what I'll do is actually move this up into here. Okay, and then let's say I'll push this here. Okay, and I'll take this out of here. Okay, and so, you know, I was just trying to show you really how to format this try catch, this situation. Now, this is not a true error by any means. It's just how I'm showing, I'm trying to demonstrate how to set up the block. And one thing is the formatting here is clearly out of whack. So I can hold down my control and do KD, type literally KD in that order. And it fixes my try catch or my formatting. So let's go in and just do a start without debugging. Okay. And really nothing's going on, but maybe if I do this, I don't know. Okay. It says here, unhandled exception has occurred in your application. If you continue, the application will ignore this error and attempt to continue. So let's say continue. Okay, so here we go. It didn't really give me the message that I was hoping for, but that's okay because we are, I promise, going to get into doing these more often than not. Okay, so let me exit this and let's keep moving on. So, you know, there are other ways that we can test for valid data as well. And we can go to some of the more traditional ways. What we could do as an example here would be to, you know, put an if statement in there as a condition of validity. And you can see that this is a double equal sign. So really what I'm trying to get at here is that if it's just empty, if whatever's on the right of this is empty, then, you know, that is going to give us some sort of validity check. And if you're experienced programmers of any other language, you've done this kind of thing already, probably. Okay. But if we look at these code that checks an entry for a valid decimal value, okay, then we're looking at this function here, this TryParse. And notice again, right here, we've got this not character here. Okay, so what I want you to kind of realize is that as a condition, we can actually have our condition within our if statement. And we can put things like are not or are, you know, equal to, we can put those kinds of things up front. And then we're checking that this decimal, and it's the decimal class, dot TryParse, and then kind of perform this operation. Okay, and then we can again put out an error. So in this particular case, I'm just checking for a decimal. Okay, and we can do this for ranges as well. In this particular case, we're saying that our monthly investment is a decimal, and we do all this conversion. And then we're saying, you know, check this particular condition, this range is less than or equal to 0. And we actually did that back here in the last video. We did the exact same thing. We were checking a range. So if the value was 500, then set or initialize our discount percent to these different percentages. So we've done that before. But in this particular case now, we can put a message box in there. Okay, and we can check for required fields. Okay, and there's this method call right here called is present. Okay, is it actually present on our screen? And it passes in 2 arguments here, and we've got a string message, and then we're saying is value, which is this here, is value equal to whatever. I guess in this case, nothing. And then we can do this kind of an operation and then return a message, return that final message, right? So we can do that kind of stuff for required fields. And now we can look at numeric formatting, okay? And so if we look at, we've got the not again and the TryParse. And in this particular case, again, what we're saying is we've got the message string and we're doing the plus equals operator name, and then we're concatenating this message. Okay, so whatever it is that you're putting in there, you're saying must be a valid decimal value. Okay, so, we can do different things with this in order to validate our user's input. And again, we can do different things with a valid number range. We can use the two pipes for or. So this number is less than minimum or number is greater than maximum. So we can then again do this stuff. So keep in mind you're using this TryParse again. Okay, so a dialog box that displays 3 error messages. Okay, I've got 3 errors here and here. Okay, so you can kind of pack these things with a little bit of information if you really want them to be. Okay, and you're noticing here my error message. Initially my error message says nothing, and then you're taking the nothing and you're adding what's going on in here, and then you're adding what's going on in here. Okay, so you're validating your monthly investment, and now you're validating your yearly interest rate. Okay, so you can kind of really pack these things tight with information you want to have. But I really want to point out this syntax here, this tag, okay? So this tag is part of the syntax as well. So, make sure that if you do want to do this, that you're adding the tag. So it's your for example, text monthly investment .tag .ToString. And this is sort of the ranges that you're trying to validate. Again, you see it down here, this .tag and then .tag again. Okay, so make sure that that is part of the syntax that you're adding. And, here's a case where you can do multiple entries, and it looks like this. So I'm entering here and I'm entering here. And so I want to have messages that handle that, okay? So it's possible to do all of that as well. What I'd like to do right now is to completely switch gears. And there's a number of things that I want to kind of go through within this. And the first one right now that I want to look at is this for each. Okay, and it's a type of a loop that you would use, obviously, with an array. But it's a little bit of a different syntax. And it's not necessarily just for arrays, okay? But let's look at this syntax. We have the keyword for each. We've got a type, an element name in array name, and then we have our statement. Okay, so if we look at this code that displays the numbers array, okay, we're setting this string. Okay, and when I say it doesn't have to be an array, I'm implying that it has to be part of a string. That's the other option, right? And so you see for each, and we're saying it's an integer. So number in numbers. Okay, and notice this one is with an S. And so what I'm saying here with this particular code is each time you loop through here, you're looping through the numbers. Okay, and notice that in this particular case, you don't see the extent or the range to this thing, right? But you're seeing what the syntax is. So numbers string is plus equals number plus this. Okay, and when we talk about which number, we're talking about this one here. And so this message box is going to return this and sort of display this as our number string. And then we're just giving it this title right here, okay, which is this. And so what I'm not showing you here in this particular example is the original array values that have been initialized. Okay, I haven't shown you that. But I wanted to just kind of introduce this idea of a for each, because we're now going to go look at a for loop, okay, and look at a little bit of the differences. And so if we talk about this block of code right here, and we're really just interested so far in the for loop. Okay, what we're doing is it's a typical for loop where we're initializing I to 0. And then we're using this I is less than numbers.length. Okay, and I want to come back to this in a second. And then we're taking, you know, I and incrementing it, and we're performing this sort of operation right here. But what I want to sort of direct your attention to is this this here. And this is a pretty common syntax for a lot of different languages. So if you've done Java, that's no different in C#. Okay, so there's this dot length thing here. And what it does is it's a length property to tell you the length of an array. Okay, so it's an important one that you really should know about. Okay, and you can see here if we're using a for loop to compute the average of the totals array. Okay, we need to use this kind of a structure here, this length. We have to use this to get that, because if I'm looking to do an average, then I need to know how many to divide by. Okay, so this is really an important thing to understand right now. It's going to come up in the future. Hint, hint. And so, you know, they perform in a very, very, very similar way, but our syntax is just different. So if we compare now, go back to the for each, and we look at this, we're saying decimal, okay, total in totals. Okay, it's a different thing. And here's the interesting thing. I'm calling the length on totals with the S. Okay, so I'm getting my sum, and which is a product of this calculation here or this operation here, and I'm dividing by the totals, the number of the totals. Okay, and then I'm assigning it to this average. Okay, so again, the for loop and the for each, you can call the totals within the operation, or you can call the length in there. Okay, so it's important that you understand that. I can't stress that one enough. And I want to take a minute here also and talk about this get length method. Okay, and when we deal with this, in this particular example, let's say we have a two-dimensional array. We've got rows and we have columns. Okay, and when we look at this again, you can see it's a nested for loop. We've got the outer loop and the inner loop. And so what we're doing is we're saying, okay, check my outer loop and get the length. Okay, and then check my inner loop and then get that length. Okay, and then process the rest of this loop. And you can see the example here. What's happening is you've got this 2D array that is putting out the inner and the outer. Okay, and for clarity's sake, I want to make two distinctions. This is actually referred to as a property. Okay, and you look at the description. It says gets the number of elements in all of the dimensions of an array. Okay, so that's the number of elements we have in our array. But contrast that with these here. These are instance methods. So there is a difference between the length property. And when we want to use it, we use the dot operator for the length property. But we can also call our methods for getLength. And this gets the number of elements in the specified dimension of an array. Okay, and then thirdly, there's this getUpperBound. And so it's important that you do have an understanding that there is a difference between the length property, and it gets the number of elements, and then in all of the dimensions of an array, so a one-dimensional array. And then this one is more, say, commonly used in a multi-dimensional array. And when we get into arrays, we actually have these static methods that we can call. So we've got copy, we got binary search, we've got sort. We can do these things, okay? And here's a good example. We have an array of numbers, okay? And these are each of the numbers. And we want to assign what length is. And this is a difference between we use getLength with numbers. And then once we perform that, we then assign that to length, which is different than capital length, okay? It's a different thing altogether. We're just doing two different things. But if you look at this, we can get an upper bound inside our array as well. Okay. And here's an example of sorting. If I have an array of last names, I can just kind of do it in this manner. And you look here, I'm using a for each. Okay. So I'm going to give you obviously all the slides for this, but if not, you can get them at Murac Books, edition 7. Or get the book. It's an awesome book. But anyway, all that content is in there. So yet again, I do want to switch gears and kind of move away from the for loops. And I know that this piece is a little fast and furious, but you can go through the slides on your own. But understand that with a string, strings we say are we can say characters, and we can A, B, C, D, all the way to G, right? As a string, but we can do an individual one as well. So we've got this idea that a char A is just kind of the first character, or is a single character. So there is a distinction there. Okay, so if we look at common properties of string classes, and we've got sort of this length between a string and an array, this property of length does exist. It's usable in both cases. Okay, and if we look here, we see length shows up again, which is great for us. But we also see that a for each we can use again with characters. Okay, so for loops and for each, we can use them for both situations. We can use them in arrays, and we can use them in characters. Okay. Now, I'm sure you don't know, but there's a build-up, because there's a slide that I want to get to that's really important, and it's going to impact on future work that you're going to do very soon. But I think what I want to do, I want to just really briefly cover dates and times, really briefly. And then I want to go to some strings, because there's some very, very important and special methods that we need to know about so that we can call them on strings. Okay, so really, if we want to say how to create a date time value using the parse method. Okay, and you can see that date and time really are data types. Okay, and then I'm saying, okay, the name of the variable that I want to have is string date. Okay, and I call this new date and time. So this is kind of the syntax or the statements to create date time values. And you're going to need to know how to do this, right? Especially if you're making an application that requires a date to be put on it, or you're trying to do record keeping of all of your invoicing. The customer is going to want to bill with the date and the time that they purchased an item. So these things do all exist in C#, definitely. And we can look at some of the formats here, right? So this is day, month, year, month, day, year, and other syntax. Me personally, I prefer to see it these bottom two. So I know there's no confusion between this number and this number. Sometimes it's hard to tell. Like, look at this one here. Is this the 1st of January? Yeah, it is. That's an easy one to tell. But what if this was, in this particular case, let's say 0112. Okay, is it January 12th? Or what does that mean? So I don't really like that. I do prefer to see this kind of a syntax where the month is spelled and the date and the year are put in there. And then time formats as well. Okay, so we've got these two properties, now and today. Okay, much like length is a property, we have this now and today. So you can see that we've got our current time date equals to date.now. That's what's happening now, or what's happening today. Okay, so there are these different methods that we can call. Too long date string, too short date string, all these different method calls that we can use to manipulate dates. Okay. And here's some more examples on the formatting of dates and times. So there's these are the properties that we're working with dates and times. So date, month, day, year, hour, minute, second, time of day of week, and day of year. Okay, and then there's methods that are specific to that. So this is the methods that you want to call, and these are the properties. Okay, and then you can see what's going on here. Date time, current date time equals datetime.now. And this is kind of the output that you would get from this. And if you're trying to capture, okay, what is my month? And it's just current date time dot month. Okay. And so you can perform these operations here on the right side, and then assign those over to variables and then manipulate your variables that way. Okay. And so here's kind of an important slide, and I left enumerations to this point because, you know, typically when you learn about an enumeration the first time, this is usually the example, the days of the week or the months of a year. Okay, and what you're seeing here is this enumeration being used. So we have day of the week is calling .Saturday. Okay, so day of the week is this property in the enumeration that we can use. Okay, and so there's methods for performing operations on dates and times as well. Add days, add month, etc. Okay, add is just time span. Subtract, date time. Okay, so there's operations we can do with dates and times specifically too. Okay, and then here's statements that perform operations on dates and times. And take note of this one, this parse, okay? Because this is a string that's happening here. Okay, so we're parsing this string, and then, you know, this is a right-hand side of the equation. And once that is completed, then we're assigning it to this date time variable, which is of data type date time. Okay. So this is really the slide that I want to spend a little bit of time on. And you can see I've changed these specific methods for a reason, because if you're watching this, you need to investigate this. You need to learn everything about these. So for my students, that means, guess what, guys and girls? You need to have this because you're going to use it on your next assignment. So starts with, ends with. The other ones are important as well, but remove, substring, to lower, to upper, trim, and split. Okay, these are important. And so let's go through the important ones. Okay, and understand that starts with and ends with are really evaluating to Booleans here. Okay, so if we look at this, we're saying chars dot starts with ABC, okay, true or false, okay, and ends with ABC. So if we're talking about the alphabet, okay, this would be true. If, again, the alphabet, it ends with, no, it's XYZ. And so that's why this is false. So this is how you look at starts with and ends with, okay? And we've covered those two, and I want to go to remove. So before I can get to that, though, I need to explain this idea of a string builder. And when we've talked about strings in the past, strings have this idea of it's got a fixed length and a value. And so when the string class creates strings, it's referred to as being immutable because of this fixed length and value. But when you assign a new value to a string variable, the original string object is deleted and then it's replaced by the string object with the new value. But the other thing that we can do is this idea of a string builder. Okay, and it's in itself is a class, this string builder. And you can see here on this slide at the top, we're using the keyword new string builder. Okay, and this is how we convert strings, actually make them mutable, so that we can add and delete or replace characters in that string object. And so this is why we use this string builder class. And with this, we can start to look at these specific string builder properties and string builder class methods. And so we have these ones here, and I believe the ones I'm really interested for you guys is really these ones here. And notice this one here, this toString, comes from the string builder class. Okay, and here's this old chestnut again, length. Okay, so understand that these are involved in the string builder class. Okay. All right, what's an example maybe? Let's first look at the syntax to this. It's a string builder class, that's our data type, our variable name. And then we use new, and it looks to me like it's just calling the string builder constructor, and then that's how we're gonna create our new object. Okay, so if you look at this one as an example right here, right off the bat, we call this one argument constructor and we assign it the capacity of 10. Okay, in this original initialization of address 2. Okay. And here's the thing that you have to understand. We need this system.text reference within our code. Okay. And we haven't had a chance to talk about references yet. And I'm going to close this particular one because this is what we've been using so far in the past. We don't have our system.text. And the moment that we have a requirement to call that class, we will be notified. We'll be given almost an error with a little light bulb. Okay, so let's see if I can just type this in somewhere and see if we get the issue that I'm talking about. So if I say string, and does it show up on here yet? It doesn't show up on here, but if I say string builder and I say var name equals, I don't know, new string builder, and in here I've got a parameter list. I don't know what I'm going to put in there yet. I'll just put in nothing for now. You're seeing that I'm getting this warning, right? And I can do the drop down, and you can see right here it's saying my suggestion is that we use system.text. And so if I click that, you can see that this particular error goes away, but at the very top, it added in the reference to that class where I can find some more meat and potatoes about my string builder class. Okay. So I guess really, you know, we go and look here on the next slide here, and we've got sort of examples of the string builder class, but let's go see what we've got here. And what we're seeing is that the code that creates a phone number and inserts dashes. Okay, so remember what I said, it's kind of overwriting the string, right? And if you look at what's a good example here, we've got, let's say 10. We've created 10 here. And what can I do with this? I've got my insert, and I've got remove, and I've got replace. I have all these different sort of options available to me now that I've got an instance of my string builder. Okay, so phone number now, because it was created from the string builder, can now implement all of these different methods. Okay, and notice here that we've got ToString in there as well, down at the bottom. Okay, so what do these mean in terms of formatting? Yeah, you know what? We'll come back to this another time. How about that? It's in the slides. It's probably really important to what you need to do in the very near future. So, have a look at that as well. But right now, I'm not overly concerned about going through it. What I really want to get to is these methods that are not part of the string builder. Okay, and what we have is remove, which is one that you should know about. Okay, and when you look at this, you're just removing something from the index here. Okay, so understand what's sort of happening in the code on that particular line right here, this line here. But notice we're calling this, and we've got 2 parameters, not 3. We've got 2 parameters in there, and then we have insert as well, and finally replace. Okay, so these are ones that you definitely want to understand or know about. Okay, and let's keep going in this. And talk about parsing, because we have this one here, this trim function or trim method that we can call. And so you can see Edward C. Coop. Okay, and that's how it's printed out. But notice there's this space at the end of it. Okay, and it's actually hard-coded right in. But then when we want to trim that, we can actually do that. And what it does is it takes kind of the last space between your last character and the quotation, and it trims that down. Okay, that's one that you should know about. And maybe another one here is substring. Substring would be an important one maybe to understand as well. Okay. And these are all things that if you don't know how they really work, and I'll show you how that's done. So let's take this focus method right now. And if I highlight that and I right click on it, what I can do is I can go to implementation. I can go to the definition or peek it. I can view the code. Okay. So I can get a lot of information about that. Just by going through and understanding sort of these drop downs here. So if I were to go to definition, okay, you can see in the back, it's telling me where that thing is located. And this is a control file from metadata that probably holds no interest for you at all. Okay. But let's say you're the one who created the function somewhere. You want to be able to be taken directly straight to that implementation. So let's say I have this different example here, and there's a function that's been written in here, like this one here. Okay, I'm actually in the implementation, so maybe that doesn't really matter. But let's say I want to go to find all references. Okay, I can do that down here. In terms of where it's being referenced each time, that's one thing I can do. I can get a lot of information about this particular thing just by highlighting it and right-clicking. And to say go to definition, the problem is I'm already in the definition of it because these functions are written here. But let's say I create my own classes in different locations. I can now bounce between 2 different files. Okay, so that's kind of an interesting thing that it can do. So this slide is slide 22. It's in chapter 9. And I want you to look at all of the things that this particular slide is doing. Okay, we've got an address, a string address. 805 Main Street, Dallas, Texas, 12345 with a space. I'm taking the address and I'm trimming the address. Okay, then I'm checking to see, hey, does it start with this pipe? I want to do some, if it starts with the pipe, remove it. If it ends with it, remove it. Okay. And I want to get in and start figuring out what's going on with this. I need to know the length of this address. Okay. Right here on this particular line. I need to know the length for some reason, and I want to do some removal. Okay. And I've got index of, I've got my substring. I want to look at my street and figure out what's going on with this substring street. Okay. And look at what's happening here. I'm doing the index of, okay. And now I want you to consider something. This string address, this is all one string, right? But we can go in and start taking chunks out of it. We can break it up almost as if though it is each one of these pipes is an array. Okay, so I strongly advise you to go in and take a look at this slide and start playing around with this slide. This is a very important slide on the things that you can do. Because notice here that within these if statements, I've got this variable right here. I've got another one here, another one here. I've got a string for a street. I'm breaking up this entire string address into its individual components that make up the entire address. So this is definitely a slide that you want to understand how to manipulate. Okay. And if you look at this split method, okay, do we call the split method in here? I don't see that we call split, but we definitely do trim. Okay, and we've done trim already, but look at this. We've got address trim, and then we're looking at this starts with. Okay, please focus on this starts with and ends with. Understand that. And then figure this out. But what about split? What do I do with split? Okay, split is something that I can use now to divide up into a bunch of separate columns, because the output of this is going to be something like that on my screen. Okay, really important that you understand how that's working. Okay, there's a couple others. These are for numbers, and there's one that I'm specifically looking for. We'll see if it's in here. Okay, I don't see it there. I'll search for it. We've done a lot today. Like, there's a lot of content that we've gone through, and I do apologize for rushing. But the last thing I'm going to do in this video is do this. I want to work on this exercise 9.2. And there's some good reasons why. And what my goal is for this is we'll type in our information. We hit the parse and we'll create this little dialog box, and it'll separate our email address into the username and domain name, as well as it'll format our string of address in this kind of manner. So I'd like to go through and do that now. But I know this video is getting a little bit out of control in terms of how long it is, but I'm covering a lot of stuff. So let's go and do that now. So I'm in here with the brand new project, and it's going to be a Windows Form app. Okay, and I'm going to just call this address parse. That's all I'm going to call it. Okay, and I'm going to do a little bit of work to set it up so we can get into the code piece. So I'll be back in a second. Okay, so I'm here in Visual Studio, and I've created this form. I'm not going to deal with any of the labeling, but I've redone all my labels, all my text boxes, and my buttons, and I've set this to actually go to the center of the screen. Okay, so you can see that it all is there, and clearly nothing works at all. Okay, and so now for me, I think the first thing I'll handle is I'll go to the exit button. Okay, so I'm now inside the code piece to this, and the easiest thing for me right now to do is actually handle the exit. So let me do that really quickly right now. And the easiest way to do that is to select the box and double click that. And normally you would get this thing showing up as a method call. And you may end up getting an error to that, but so I don't know why, but I would suggest that you try maybe building it and then running it, and if not, shutting it down and then opening it back up again. There could be many reasons why it's just not playing ball. But so I've clicked on the exit button, and this one is simple. This is just this dot close. Okay, and if I type in L, it gets me closer to the one I want. And so I know that my exit button now is going to work just fine. Okay, so I'll save that. And let's go back out to the form. And this is where we really are going to get interesting. So I'm going to go to my parse function, and I'll double click on that and see that parse actually shows up right away. And so, what do we have there? I've got an email here, and an email address is typically going to have an @ symbol in there. Okay, and so what I'll do is I'll do a string, and I'll call it email. Okay, and this is txt, and it's looking for email, which is right there because I put that in there properly. And then it's a text, and I'm going to call this trim method. Okay, and so I'll go down to the next line because I want to trim this, and I want to put this thing into two different things. So if I say int domain index, okay, and I will take my email now that it's been sort of created, and I'm going to say index of. So I'm calling the index of method. And within that now, I can have my @ symbol. Just like this. And then just past that, say, hey, what's after it? Okay, index of the @ and then +1. And we'll finish that off there. And so we're going to look at a condition right now. And we're going to say if my domain index is greater than 0, then what happens next? Okay. Then I want to take my string, and I want to say user name, and it's going to be email dot substring. So I want a substring out of this. And if we look at this, we're going to say 0, comma, domain index. Okay, so we did that on line 28. And then we're going to say -1. Okay, and we'll finish that off. Because now you have to understand we're breaking this up into two parts. So my domain index is kind of set in that position of 1. Okay, and so then we go to the next one, so string, and I'm going to say domain name now. Okay, because I've used domain index, but now I'm going to say domain name. So that's like, who am I getting my email from? So I'm going to say email, and this is going to be a substring again. A substring, but in this case, I'm going to really just say, this is almost like saying, get me the rest of it. So domain index. Okay, and so I'm good there. I've got those two things. And now I want to have a message, because if I don't get what I'm looking for, I need to have a message. So I'll say message, message box dot show. Okay, and what do I put inside this? And this is where I'm going to have more of a longer thing that I've got. So user name, and I'll put a colon and then a space there. Okay, and then I'm going to concatenate this. So I say user name and another plus to concatenate. And now I want to use my escape character, my new line escape character. Okay, and so I'll do this, and then again, one more plus. Okay, let's go down to, oh, just keep it on that line. So now I say domain name with a colon, right, a space, and I'll finish off the bracket because I can see I was getting the error, plus domain name. Okay, not index, domain name. So domain name, comma, and then I'm going to say, I'm going to put a string in there that says parse string. Okay, and finish that off, and it looks like it's angry because I don't have a semicolon. Okay, so that's the first part of my if. Now else what, what's going on next? So within my else, and like I said, I like to use a lot of screen space. I think it keeps the code clean. I'm going to say message box dot show, and in here I'm going to type this email address must contain an @ symbol. Okay, so this email address must contain an @ sign. Okay, and I'll finish that out. And then I'm gonna say, I'll put this here, entry error. Okay, it's another note, entry error. And finish that off. Okay, so that's kind of that piece there. And then what's the final thing I want to do? I want to refocus that on my txt email. I want to focus my cursor there. So focus, and I'll call that and end it off. Okay, so I'm good right now. And let's go. We're gonna save this, and I don't see any errors or warnings. But let's go and do a test without debugging. Okay, and let's see what we're gonna get here. So Tom at home. Okay, let's see what happens. I hit the parse button. And so now I'm getting this message here that says, Tom, it's broken my entire string into two pieces and into my name and my domain. I'm getting a message on my message box. And what if I say, if I actually don't have the @ symbol? Okay, and we try that. And it says right here, the email address must contain an @ symbol or an @ sign. Okay, so that part is good, and I'm relatively happy. Now, what about this? So let's now, let's click on our double click on our format button. So I double click on that, and I can't because it's actually the compiled version of this. So we'll exit this, go back to the form, and look at format. I'm double clicking format, and you can see that right below there, it's all happening for me. Okay, so this is not too bad either, what we want to do, but we're going to say string city is going to be the input from the text box. So text city dot text, and we're going to trim it again. Okay, and we'll finish that off. We're going to say string. What did I call it? I didn't call it I called it a province. So province. Okay, because I live in Canada. And we're going to say txt prov. Okay, right there. And again, it is a text with a trim. Okay, just like that. Go to the next line. And now we're going to change this to an uppercase. Okay, so I want to change, if I put it in lowercase, I want to change it to an uppercase. So I'm going to do prov and province. I want province to be changed now. And I'm going to say province dot to upper. Okay, and this is, I'm just going to call this this method now, and that's all I want to do with that. And then the last thing is string um, uh, postal code is going to be equal to txt postal code, and it's text, and I want to trim it. Okay, and end that with a semicolon. Now, I need to now know the length of my city. Okay, so what I'm going to do is this. I'm going to say int because I'm looking for a number, and I need city length, and I'll do it this way. So city, okay, dot length, and it's capital L. And remember, that's a property. That's not a method call. And so I can do this string city prov and postal. Okay, and because this is a string that's going to be concatenated, and if you look at it this way, city, okay, plus province, okay, plus the last thing is our postal code. Okay, so that's the last thing there. And this I want to be able to do some insertions on, okay? And so when I look at this, I say city prov postal, and I'm going to do this. City prov postal is going to be an insert. An insert, and inside the insertion is going to be city length. Oops. So city length, and then I'm going to say +4. Okay, and then past the comma, I'm going to put quotations with a space. Okay, because I want there to be a space in what I'm doing. And in fact, I don't want to do this line first, but it's so close to my other one that what I'll do is I'll copy it and I'll put it down here, and then I'll make a couple of changes to this right now. Because I want to actually, the only thing I want to do right now is take this out, and inside here I want to add a comma. Okay, so I want to deal with, let's say, the city length and +4, and then do a space. Okay, so after I've got this line, now I can do another message box. Okay, and message box, and this is going to be dot show, and inside this I'm going to say 2 quotes. It's going to say city, comma, province, comma, and postal code. Okay, that's what it'll say there, and I'm gonna have my colon, give it a little bit of a space. Now I can start to concatenate my city, province, postal. Okay, and add that comma, and then I'm gonna have another message say formatting string. Okay, and so really that's all there is to it, other than txt for city is going to be my focus. Right, and that's it. That's all I'm doing here. But let's go ahead now and have a look at the result. So I'm gonna save this and just go and test out that one thing. So if I say Utopia in Ontario, and notice I'm putting all lowercase for that, and postal code is A1B 3C 4. Okay, and now I'm going to hit the format, and you can see what's happening here. Okay, and it's really important that you understand that I've taken 3 different things, I've parsed it into one. But look at right here, Ontario. Ontario has now been capitalized. And I know that there's an error. I probably just, in my formatting, missed a space somewhere. That's not a big deal to me. But understand what's happening in this is that I did type in province, but I changed it to an uppercase Ontario. All right. So very, very quick and dirty, but that's sort of some of the things that we can do with what we were talking about earlier with those very special functions or methods. The to upper, the trim, insert, show, and some other ones. So very, very quick and dirty. And, this index of was kind of an important one that we needed to know about. Anyway, this video, unfortunately, I do apologize, has went on way, way too long. But anyway, thanks for watching it, and I will see you soon again.